Good afternoon, dear colleagues and friends, guests. Today is the 19th of May 2022. It's 4 p.m. Moscow time. Let me declare open a session of the Decision Council for the defense of thesis by Kornyakov Ilya Viktorovich for the degree of Candidate of Geology and Mineralogy, Specialty 164, Mineralogy, Crystallography, Geochemistry and geochemical methods of mineral exploration on the topic Synthesis and Crystal Chemistry of Novel Mineral-Related Divalent Copper Compounds. By the order of Academic Secretary of St. Petersburg University, Gniodov Alexander Valentinovich, dated the 15th of March 2022, number 2271/1, May, Zaitsev Anatoly Nikolaevich, Doctor of Geology and Mineralogy, Professor of the Department of Mineralogy of St. Petersburg University, was appointed Chairman of this Dissertation Council. Other members of the Council were appointed with the same order. Let me introduce them to you. Bruce Nitsin Alexeyevich, Doctor of Geology and Mineralogy, Professor of the Mineralogy Department of St. Petersburg University. Olga Viktorovna Kamenetskaya, Doctor of Geology and Mineralogy, Professor of the Crystallography Department of St. Petersburg University. Belagub Elena Vitalina, Doctor of Geology and Mineralogy, Associate Professor, Deputy Director for Research, South Ural Federal Research Center for Mineralogy and Geoecology, Ural Branch of the Russian Academy of Sciences. Pekov Igor Viktorovich, Doctor of Geology and Mineralogy, Professor, corresponding member of the Russian Academy of Sciences, Senior Researcher of the Geology Department, Lomonosov, Moscow State University. And in the remote access mode, we have the following council members. Tatiana Borisovna Becker, Doctor of Geology and Mineralogy, Professor, Russian Academy of Sciences, Senior Researcher, Sobolev Institute of Geology and Mineralogy, Siberian Branch of Russian Academy of Sciences. Tatiana Borisovna, can you see and hear us? Yes? I can see and hear you. Thank you. And Frank Christopher Houghton, PhD, Professor of the Manitoba University, Canada. Professor Houghton, can you see and can you hear us?
I can hear you. Can you hear me?
Так, не слышу ответа. Видит, слышит, все хорошо.
So all is well. And the degree applicant, Kornyakov Ilya Viktorovich, is also present. The thesis supervisor, Doctor of Geology and Mineralogy, corresponding member of the Russian Academy of Sciences, Professor of the Crystallography Department of St. Petersburg University, Sergei Vladimirovich Krivovich, is also present. In order to improve the quality of communication, dear colleagues working in the remote mode, please turn off your microphones, but please remember to turn them on when you're given the floor. Let me also inform you that our session is being recorded and broadcast live at St. Petersburg University website. The speeches are being translated simultaneously from Russian into English, from English into Russian as appropriate. During the live broadcast, during our session, an email is displayed to which all the listeners may send questions to the applicant or their opinion related to the thesis and the applicant's presentation and the ongoing scientific discussion, and thus take part in the discussion. These questions shall be forwarded to me by our technical department, and I shall present them during the discussion. Questions should be related strictly to the applicant's speech and the content of his thesis, and it's necessary to indicate full name, title, and place of employment of the author. Questions that are not related to the scientific discussion, the text and assessment of the thesis, as well as anonymous questions, should not be presented. In accordance with the order of awarding academic degrees at St. Petersburg University, approved by the local regulations of St. Petersburg University, hereinafter referred to as the Order, a session of the Dissertation Council shall be considered competent if at least 2/3 of the appointed members are present, but not less than 4 persons. Our council consists of 7 persons. All 7 are present, including 2 council members working in the remote interactive mode. Audio and visual contact has been ensured. Thus, we have the quorum. I invite the officer of the Dissertation Council Activity Support Department to draw up the attendance list. Let me set forth the following procedure of today's session of the Dissertation Council, with a total duration of approximately 2 hours. First, summary report of the chairman on the applicant and documents submitted by the applicant and their compliance with the applicable regulations, answers to possible questions. That should take approximately 5 minutes. The applicant's presentation outlining the key findings of his research. We agreed to allocate 20 minutes to that. 3 questions to the applicant related strictly to his presentation and answers of the applicant, no more than 5 minutes. 5. Presentation of external reviews, if any. Number 6. Speeches of all the council members in turn with their evaluation of the thesis and the applicant's speech, as well as questions and suggestions to the applicant. Each speaker will have approximately 10 minutes. Speech of the chairman with his evaluation of the thesis. 8. Answers of the degree applicant to questions and remarks made by the council members, no more than 20 minutes. 9. Open discussion. Speeches at will of the attendees with summaries of their positions and or specific questions and suggestions to the applicant, strictly on the topic of his research. At that, all the speakers are kindly requested to register and introduce themselves fully before speaking, giving their full name, title, and place of employment. 10. Presentation of questions to the applicant received during the discussion and the scientific discussion during the live broadcast of the session at the university website. Let me inform you that written questions, the presentation of which takes over 2 minutes, shall not be presented. 11. Answers of the applicant. 12. Speech of the thesis supervisor. 13. Discussion by the council members before open voting. For that period, sound shall be switched off. 14. Open individual voting. Votes shall be counted by the chairman and results shall be recorded in the minutes of the meeting. 15. Making decision on awarding or not awarding the degree. And finally, we'll proceed to final remarks of the applicant. Dear colleagues, do you have any questions or objections to this procedure? No objections. If you have no objections, let me proceed to... Please remember to switch off your mobile phones. And dear colleagues working in the working remotely, please keep your phones switched on so we could reach you in case of emergency. Thank you for your understanding. Let's start our session. First, Chairman Summary Report. The thesis by Kornyakov Ilya Viktorovich for the degree of Candidate of Geology and Mineralogy, Specialty 164, Mineralogy, Crystallography, Geochemistry and Geochemical Methods of Mineral Exploration, on the topic synthesis and crystal chemistry of novel mineral-related divalent copper compounds was accepted for defense by the order of the Academic Secretary of St. Petersburg University dated the 3rd of February 2022. Kornyakov Ilya Viktorovich wrote his thesis at St. Petersburg University as a doctoral student. His thesis supervisor is Doctor of Geology and Mineralogy, corresponding member of Russian Academy of Sciences, professor of the Department of Crystallography of St. Petersburg University, Sergei Vladimirovich Krivovich. The number of publications of the applicant which set forth the key findings of the thesis according to the enclosed list is 6. In journals indexed in the scientific databases, Web of Science and Scopus, 6 publications. All the documents submitted by the applicant, according to the information I received from the curator, comply with the applicable regulations and are kept in the applicant's attestation file. Copies are available from the Dissertation Council Activity Support Department officer, who is now present. Before I give the floor to the applicant, I have a question for the council members. Dear council members, do you have any general questions to the applicant? And is it necessary to review the entire list of documents submitted by the applicant? No, it's not necessary. No questions. Summary report of the applicant. No more than 20 minutes, please. Ilya Viktorovich, the floor is yours. Anatoly Nikolaevich, thank you very much for introducing me. My name is Kornyakov Ilya Viktorovich, and today I'd like to present my report on thesis on new mineral-like copper compounds. Copper is one of the most important industrial metals. The copper content in the upper continental crust is 28 ppm, and despite its relatively low content, copper is characterized by an anomalous mineralogical diversity. In nature, copper can be found in 2 degrees of oxidation, univalent and double valent. Univalent is soft and chlorophyllc, and is hard and lithophilic, and tends to form oxygen-containing mineral species. Indeed, in more than 700 divalent copper minerals included in the approved by the International Mineralogical Association, over 440 minerals are oxygen-containing. As the diagram on the slide shows, arsenates, arsenides, and sulfates are dominant classes of divalent copper mineralogy, and 10 more percent belong to hydroxides, hydrohalides. 34% account for phosphates, silicates, tellurates, and carbonates. In the crystal structure of minerals, divalent copper exhibits several coordination geometries. The most common are the geometries of the elongated octahedron, the tetragonal pyramid, and in a very small number of minerals, copper atoms can be found in the coordination of the trigonal prism, semi-coordinated copper, and in the coordination of the tetrahedron. The reason for such a wide coordination diversity is the Young-Teller effect. The divalent copper atom on the outer electron shell contains 9 electrons distributed over 2 sets of orbitals, T2G and EG, while in the first set of orbitals is stabilized in the octahedral field, while the second set of orbitals is destabilized. The driving force behind the Young-Teller distortion is the unequal occupancy of the EG orbitals, which are separated because of the distortion. Depending on the particular orbital occupied by a single electron, compressed or elongated octagrams can be formed. The study of the distribution of bond lengths reflects dominant nature of elongated octahedrons. On the right, you may see a graph of the dependence of the average lengths of apical bonds on the average length of equatorial bonds, where the circles indicate the elongated octahedrons. As you can see, the greatest number of them is observed. Such a distribution of bond lengths in octahedrons limits the entry of copper atoms into solid solutions, and therefore leads to the formation of new mineral species, which explains the anomalous mineralogical distribution. This conclusion is confirmed by the statistical analysis of bond lengths in all most frequent geometries. The results are shown in this slide. This slide shows the values of standard diversions. With standard deviations, the small standard deviations of the equatorial bonds indicate the relative stability of these geometries. However, the equatorial bonds of trigonal bipyramids, which show large deviations, stand out from these statistics. This is explained by the possible structural transitions between the coordination of this pyramid and the trigonal bipyramid. In order to evaluate the prospects for experimental study, all the coordination geometries of copper in all minerals have been analyzed. Based on the results of this analysis, we made a structural review describing both the most common and rare ways of polymerization of copper polyhedra. Minerals were subdivided into island, chain, layered, and framework minerals, and a brief characteristics were given for each mode of polymerization. According to the results of the review, the following pattern was observed. The crystal structure of minerals with oxo-centered tetrahedrons showed the greatest variety of coordination geometries. On the slide, there is a table where minerals are subdivided into non-containing and containing tetrahedrons. The first group contains 337 minerals, of which 196 contain exclusively octahedrons. At the same time, only 65% of minerals with octahedral containing tetrahedrons contain only very simple geometries. Most of the minerals were either first described or discovered as products of volcanic excavations in fumarolas, which determined the further direction of our experiments. The method of chemical transport reactions was chosen to simulate gas transport in fumaroles. In this method, a mixture of reagents was included in the transport agent was placed a quartz ampoule from which air was evacuated, which was then sealed. As the temperature increased, the reaction occurred, and some of the substance was relieved as gas. And gas transfer from one end of the ampoule occurred where the substance precipitates, and then the process is repeated. As the transport agent, alkali methyl halides were mostly used. One of the most interesting objects of the study are recently discovered minerals ars mirandite and limonite. Their crystal structure contains clusters surrounded by arsenate. Although this type of clusters has already been known, these minerals are not hydrated, unlike synthetic compounds, but clusters are immersed in the sodium chlorine matrix, which retain the features of the halide structure. We synthesized 5 new compounds containing such clusters. The first 2 compounds were titanium and zirconium containing, while the clusters forming a 3-layer form the 3-layer cubic packing. At the same time, the structure contains additional MF6 octahedrons, where M stands for titanium and zirconium, which are located in the octahedral cavities. The sodium atoms retain features of the halide structure. So when a fluor is excluded from a new cubic phase crystallizes, it can be represented as layers inherent to the hexagonal packaging. However, half the clusters are removed, and every other layer every other layer, every second layer is rotated 90 degrees relative to the first. Between the two adjacent layers, there is an additional cluster. By reducing the oxidation degree to 3+, highly symmetric mineral analogs crystallize. The clusters packing is hexagonal, but the layers themselves are distorted, since the angles between the cluster centers, there is a deviation of the angles between 120 to 60. In addition, as the experiment demonstrated, crystallization of the purely copper-containing phase is also possible. The copper atoms located in the center and 3 ordering schemes are possible, shown in this slide. Thus, the demonstrated data indicate both the flexibility of the clusters themselves and their halide-like matrix. Indeed, the bonds between oxygen atoms and the central cation vary from 2.1 to 2.4 angstroms, and the halide-like matrix is able to adapt both to different packing arrangements and different degrees of distortion, which takes us to the first proposition submitted for defense. Due to its coordination variation, the central M position can be populated with either trivalent or quadrivalent cations. The packing of clusters can vary depending on the chemical composition of the compound. In our research, we obtained 2 new compounds that can be attributed to the family of Shurovskite. Shurovskite and mineralogy are 2 minerals, the structures of which are based on dimers of Rib-bond oxo-centered tetrahedrons. The dimers, through oxygen atoms coordinating copper atoms, are connected in chains which form layers. And the layers are connected through either calcium atoms in Shurovskite or potassium atoms. However, the arrangement of the dimer chains within the layer can be different. For example, in our compound, which can be called the archetype, the chains are located differently, and the layers are joined not through calcium but through additional copper atoms, which results in copper phosphate framework lattice. The second new compound is a superstructure with an 8-fold larger cell, which also demonstrates a different chain arrangement. Conventionally, this topology can be called intermediate between the structure Shurovskite and archetype. We can see the chains are still shifted, but the symmetry of the topology is higher than in the archetype structure. The framework of this compound is characteristic not only for compounds with dimers of oxo-centered tetrahedrons. We have synthesized 2 new compounds, the structures of which are based on chains of such tetrahedrons. The chains are connected through TO4 tetrahedrons, forming channels. Depending on the atoms forming the channels, the symmetry also changes. For example, the compounds shown in the slide, sodium and monovalent copper, lead to a rhombic symmetry structure. If we replace the sodium and univalent copper atoms the symmetry is lowered, but the framework remains unchanged, which is expressed both in the geometry and the allocation relative to each other. It should be noted that this phase is the isotypic of the mineral Uroshevskite, the structure which is based on the chains of the same composition. There are 4 phases in this series of compounds. The reduction of symmetry to monoclinic occurs when the atoms of univalent copper are replaced with, or in case of when all are replaced, and the number of 1 has already been published earlier. However, the framework remains stable, and the figure shows the relation, the ratio of unit cells. All the above facts lead us to the second provision. The structural variations in the families of phases of modules are determined by the type of polymerization of the tetrahedrons. Frames based on the dimers have greater conformational flexibility than frames based on chains of the same composition. The second object of structural study was the structural type of avirivate, which is characterized by the presence of copper atoms, layers of oxo-centered tetrahedrons alternating along the C direction, form channels filled with alkali methods and chlorine atoms. At the same time, the cesium chlorine containing phase, its unit cell is 4 times bigger, and the potassium brom containing phase first is non-centrosymmetric. In both phases, the alkali metal atoms are relatively ordered, and the halogen ions are located within the layer of oxocentric tetrahedrons. Apparently, increasing the size of the ion leads to the distortion of the coordination geometries. When the vandate tetrahedron is with phosphate tetrahedrons, the structural rearrangement becomes more noticeable. The coordination geometries of copper are significantly distorted, which is especially evident in the example of cuprum-1 atom. While cesium chlor, it occupies the triagonal bipyramid. In the rubidium chlorine phase, it becomes, and in the potassium phase, it's rather fresh-squared with distortion of the copper polyhedrons leads to a decrease in the symmetry of the framework, the displacement of the layers of oxo-centered tetrahedrons. Thus, in the cesium phase, the framework remains trigonal, while cesium is displaced by rubidium, the symmetry decreases to monoclinic. The data described above lead us to the third proposition. The type of tetrahedral complex determines the conformational flexibility of the framework. The copper vandate framework remains trigonal, regardless of the chemical composition of the M and X positions, while the symmetry of the copper phosphate frame decreases to monoclinic, with decrease in the alkali method size. When experimental work was not limited to copper compounds with pentavalent cation. In the process of studying the phase formation, we obtained 2 new compounds that are polymorphs. The first is a polymorph rubidium trichloride. So that is an excellent demonstration of the structural transition of the second order under the influence of temperature. The alpha exists at temperatures above 339 degrees Kelvin. When the temperature decreases, there is a transition, the beta modification, where a decrease in symmetry to rhombic. And at 262 degrees, there's transition to the gamma modification with monoclinic symmetry. All 3 polymorphs are examples of hexagonal perovskites with 2 and the rubidium chlorine 3 are organized in the AB-AB sequence. The new polymorph demonstrates a completely different organization. Its structure is an example of mixed hexagonal perovskite, in which rubidium chlorine 3 layers are packed in the AB-CB sequence. Instead of chains, such octahedron connect through faces. Framework is formed of dimers of 2 octahedrons having a common face, with the dimers connected to each other through common octahedron edges. The structural rearrangement is accompanied by an increase in density, structural capacity, and decrease in bond lengths. In addition, a new polymorph of copper selenite was obtained, whereas the structure of the alpha polyform is based on chains connected by selenite trigonal polymers. The structure of beta polymorphs is based on diamonds of two rebonded copper octahedrons. The new polyform is isotopic to the mineral ragit, shown here, but unlike the mineral, it's metastable. Within this work, in the beginning of this report, we noted the pattern of distribution of the coordination geometries with and without the oxo-centered tetrahedrons. Experimental studies confirm the conclusions, so 7 of 18 presented structures are based on copper polyhedrons of the same type. Thus, the structure, so 22 new compounds have been crystallized in 13 structural types. The above mentioned data can predict future minerals. According, at least 7 new structural types described in this work are likely to be found in nature. The most interesting finds are compounds with ars mirandite clusters. These 3 structural types we described earlier. The 2 compounds with mixed divalent coppers are also potentially have natural analogs, as ala halcacilite, which is also mixed divalent. The proximity of potassium and rubidium suggests the existence of natural analogs of rubidium copper selenites. The listed results of the work lead us to the 4th defended provision. The conducted results show the great potential of the method of chemical transport reactions for obtaining artificial analogs of minerals and mineral-like compounds of copper, which is confirmed by the synthesis of 22 new compounds crystallizing into 13 new structural types. As a result of this work, 6 articles were published in peer-reviewed journals, and part of the theoretical work was presented at conferences. Thank you for your attention. Thank you, Ilya Viktorovich. Now we will proceed to questions of the council members. And Olga Viktorovna, do you have any questions regarding the presentation? Ilya, could you please tell us why you've chosen the method of chemical transport reactions? Please speak in the mic. So please tell us, why have you chosen the method of chemical transport reactions? This method has been investigated by our department for over 30 years, and it was first applied by Stanislav Filatov, and over these years it has proven its usefulness. And since, as I said, the oxo-centered tetrahedrons have the greatest coordination diversity, so that appears to be the most interesting topic for investigation. That's why we've chosen it. Olga Viktorovna, is that all? Igor Viktorovich, welcome. Ilya Viktorovich, first of all, thank you for your interesting presentation. I have two small questions. The first question: when you identify copper-centered polyhedrons, you include certain number of ligands, oxygen or oxygen 2 plus. What is the distance limit So obviously, the greater the distance, the more ligands you get. So what, to which distance did you limit yourself? If we talk about about oxygen, room O2, so we 3 angstrom, because a council member, Professor Horton, in 1995 made some quantum chemical calculations, and he determined 3.2 angstrom. And our colleagues, chemists, keep saying that the maximum can be as 2. So the rest is van der Waals interactions. So we calculated and decided to set the limit at 3 angstrom. And if we talk about copper chlorine, so we set the distance at 3.1 angstrom. Thank you. And so what about valency? It's with oxygen at 3 angstrom, 0.28 thousandth. That's what I wanted, exactly what I wanted to say. Can I ask another question? Different, from a different field. Have you ever come across in your esmeraldite artificial phases real dimorph couples? We have reasons to believe that dimorphism is these minerals have it in nature. Have you observed that in your synthesis? No, I don't remember anything like that. So we obtained a number of phases. Maybe I missed them, but I have not witnessed any. Nothing hexagonal. No. These structural types, these are the structural types that we observed. Nothing else. Thank you. Elena Vitalievna, welcome. I have 2 questions. The first question is of general nature. Can you explain why in your study of these structures you are using 2 different approaches, and why cation-centered structures or anion-centered structures? So these are descriptions of the same structures. Why are you using one, and why are you using both? Here it's all about the chemical role of so-called additional oxygen atoms that at the same time play their own have their own role. In an overview of 1990, Sergei Vladimirovich Krivovichev, Stanislav Konstantinovich Filatov established that when studying thermal expansion of certain minerals with oxy-centered tetrahedrons, expansion is easier and more logical to describe the expansion within the framework of anion-centered tetrahedrons, and it has, and if it has such physical explanation, why not use it? That's one thing. And secondly, that the structure is more beautiful. I don't mind, but why not take up chlorine-centered? They're also copper-centered. I think they have different valent effort. And I also have a specific question. In slide 24, you said that halogens are inside the oxy-centered octahedrons. How is that possible? So that was a slip of my tongue. They are inside the channels, inside the layers. Thank you. I'm satisfied. Thank you. Thank you. Alexei Ilyich. Well, in reality, Olga Vitalyevna already asked my question, but I will expand on it. have you noticed any cases where you interpreted from cation-centered and the same structure you described from the point of anion-centered approach? Yes, arivite like compounds, their overall structural organization is from the point of aesthetics. It's better to ascribe it from the anion-centered. But if we take up magnetic interactions of copper cations, and there is some science on that, is easier to the cation-centered, and the upper figures obviously we selected for cation-centered, though they are not shown here, but the general figures they demonstrate anion-centered tetrahedrons. Thank you. Tatiana Borisovna, you have any questions? We're happy to take your questions. Dear colleagues, Ilya Viktorovich, I have a small question. Please tell us, what were the criteria for selection of for compound selection? Please explain. You have a very diverse collection of compounds. Thank you for your question. Of course, before we obtained each compound, we made several attempts, more or less successful, these attempts. And initially, we started with molar ratio relating to stoichiometric coefficients of compounds we wanted to obtain. But in the future, it became purely empirical. And maybe it would be logical to decrease the amount of transport agent. And in my thesis, you may find some results of successful attempts, and the ratio of reagents were mostly empirically selected. I see, thank you. More questions, Tatiana Borisovna, is that all? That's all at the moment. Professor Horton, would you like to ask any questions or comments, perhaps? Please turn the microphone on, please.
In the structure of K4, Cu2 plus, Cu plus twice, chlorine 8, H2O, there are two monovalent copper ions coordinated by chlorine. Moore and Araki showed that in disonite, copper plus is coordinated by a tetrahedron of arsenic 3 plus ions. In cuprite, monovalent copper is 2 coordinated by oxygen. And we see similar in paramalaconite, Cu4O3. Monovalent copper shows an incredibly wide variation in coordinating anions. Far more so than any other metal ion I'm aware of. Do you have any ideas why this is the case?
Could you please repeat your question?
Could you repeat the question, please?
Okay. Monovalent copper shows a very wide variety of coordinating ions. chlorine in one of the structures that you've done, arsenic 3 plus in diazonite, oxygen in cuprite and paramalaconite. No other metal ion shows that breadth of coordination by other ions. Do you understand why this happens?
Честно говоря, я, наверное,
Unfortunately, I think honestly I cannot answer this question. I'm not sure, but we may suppose that the key role is because of unequal orbital occupancy, and because of unequal occupancy is about coordination geometry, but I'm not sure of my answer.
That's fine. It's a very difficult question.
Yeah, Professor
But
Croton,
you
other
could think
questions?
about this in the future.
Еще вопрос?
You have more questions?
Yes, yes. You show that anion-centered copper structures range from isolated tetrahedra to frameworks of tetrahedra. Is there any systematic variation in the coordination of copper from structures with isolated OCU4 plus tetrahedra to frameworks of OCU4 plus tetrahedra?
вот я, честно говоря, не рассматривал.
I have not thought about that. I have not thought about copper geometry in different polymerized complexes. That is why maybe I'm not sure what to answer, but if my reasoning is right, the coordination number of copper should increase.
Okay. And I have a last
И у
question.
меня есть еще один третий вопрос.
Some ions form single
Некоторые
anion-centered tetrahedra, like copper. Divalent copper, divalent mercury, divalent lead, for example. Others don't. For example, magnesium, aluminium. Why is this the case? Do you understand?
У вас есть. Опять-таки нет, наверное, я не отвечу на данный вопрос.
Again, I think I won't be able to answer this question. Nothing comes to my mind.
No, okay, that's fine. It's a difficult
Все хорошо,
question.
это тоже трудный вопрос.
Okay, that's fine for now. Thank you.
Спасибо за вопросы.
Thank you for your questions. And maybe the last question, if we will be mine, if you look at question at slide 10, have T1, T2. So that was in vacuum. So can it impact all your reactions and all your synthesized phases, and how did you control pressure? Yes, indeed. So pressure has a major impact, both of vapor, the vapor phase, and if there is some remaining air. Yeah, we controlled pressure. We took certain amount of mixture. It was more or less standard for all the syntheses, and the ampule length was more or less standard. But not always we managed to control the pressure. Some reagents are hygroscopic, and when they accumulate lots of water, the pressure of the vapor phase inside the tube can be very significant. So we tried to use a particular amount of substance for a particular volume. That's how we controlled pressure. And can you give us any numbers? When you mean significant pressure, how significant is significant? Is it 1 kilobar? No, I cannot give you any numbers at the moment. I see. Then maybe we'll stop taking questions. Next point is presentation of external reviews, and as I understand, we have not received any external questions, so we could proceed to the next stage, that is presentation of the council members' reviews. And since all the reviews were published at the university website, I suggest we all focus on the key points, key questions or comments. Do council members have any objections? No. Please don't read the entire review. No. Okay, Olga Viktorovna, could you please start with your review? Dear colleagues, I will now express everybody's opinion, which in my opinion is, in my mind, is very good. And if I had to choose one word to characterize this work, the word would be harmony, or balance. This thesis very well combines the theoretical and the experimental, the empirical part, which complement each other. And this statistical or theoretical part indicates the high level of knowledge of the applicant, and certainly all the results are valid, appear valid, and the amount of work is impressive. But there is also one more thing, maybe not the most important, but it's very important. The work is very well written and well illustrated. Over the years, I've seen many certification papers, so I have a certain reflex to take up a pen and start marking. But reading Ilya's thesis, I don't want to mark or correct anything. The work is very well written, with all respect to the readers. As for critical comments or remarks, of course I have some, that's inevitable, but they are not of conceptual nature. So the first remark, or the first comment, is about the work has no provision on the first statistical or theoretical part. If we look at tasks, they are 3, and 2 tasks are connected with that theoretical part. And novelty, of course, the novelty of results is mostly in this part, and in that section also it's obvious. But if we look at the amount of work, the amount is practically the same. The amount of, the sections dedicated to the theoretical and experimental, but there is no provision submitted for defense. So I think I would like the applicant to explain why there are no provisions. Let me ask all my questions. The second question is also connected with the provision submitted for defense, provision number 4 this time. To me, it's not clear what's its meaning and scientific novelty. The chemical reactions method used, and he explained very well to me why this method was selected. But this method has been in use for a long time in different systems. Its efficiency and potential are obvious. So why do you need this? Why did you need this proposition? And my third question is very small. In the first part of your thesis, you have discussed in detail the main points of formation of oxygen-containing minerals, not only about the natural fields, but also talks about on material artifacts. But he always forgets about minerals of divalent copper, the oxalate made copper, and the overall conclusion is that the thesis by Ilya Viktorovich Kornyakov on the topic we all know corresponds to the key requirements set by the order on awarding academic degrees at St. Petersburg University, and the degree applicant Ilya Viktorovich Kornyakov deserves awarding the degree of Candidate of Sciences, specialty 164, Mineralogy, Crystallography, Geochemistry, Geochemical methods of mineral prospecting, exploration. Thank you for your attention. Perhaps we shall take all the reviews. Igor Viktorovich, your opinion, please. Your review, please. I will be brief. Maybe my evaluation of this thesis is very high. This indeed is a comprehensive study and in its different parts the applicant demonstrated that he is indeed a highly qualified expert in chemical synthesis, shown in the slide 10, and X-ray structural analysis of very complex compounds, and crystal chemistry. These are two different things, and not all. So they don't go together. So we all know, we all know that. But it's a pleasure to see that Ilya Viktorovich indeed combines this knowledge of the understanding of both fields, and is discussion of comparative crystal chemistry. But from consumers of such structural information, let me say that it's very useful. This information will be very useful for those studying mineralogy, not only in fumarole formations, but also again mineralogy. And indeed, this is very comprehensive, and especially I'd like to praise the overview, which is truly analytical, which is very rewarding. The analytical review is different from pure enumeration, and here we can see the real analytical overview. Review all this. All these things make the thesis valuable and indicate that the applicant indeed is a real professional, a real expert. And speaking of critical remarks, I will only give one, which I find it essential, and maybe Ilya Viktorovich will keep in mind in the future. Of course, the radiostructural analysis is an excellent method, but the compounds, especially those which have many components with large cations and unoccupied positions, to make formulas only on the basis of structural data maybe is not a very good idea. We lack verification with independent methods. The electron probe analysis should be used with base metals. Especially, you have a 6-faceted ampule. So that will be the only essential comment. And I agree with Olga Viktorovna. I think the fourth provision is very trivial. Since I have been on this commission for many years, I take as a very mechanistic approach to these provisions, but of course all these comments do not have method on the overall quality. And like to congratulate the crystallography department on training, producing such an expert. So my opinion is certainly positive, and the thesis certainly complies to all the regulations applicable to candidate's thesis, candidate of physics and candidate of geology and could be chemistry also, but I think crystallography, geochemistry is also okay. Thank you. Your review, please. First of all, I'd like to say that I liked the thesis very much. It's a pleasure. It's a rare exception. The language is very lively. The understanding is good, and the very complex phenomena were explained perfectly. So I support the high opinion of the overview, literature overview, which has great practical significance. This overview can be used, for example, when lecturing in crystal chemistry, and that is very good. So I won't praise the applicant anymore. Proceed to critical remarks. I have the same comment as Igor Viktorovich on the need to measure the composition of obtained compounds, because, for example, when discussing the Cherovskite family, one formula, you have coefficients up to the third period. And how can you obtain such accuracy without the probe analysis? So this I think is incorrect, and please consider this in the future. That's the first thing about composition. The same is true about the composition. You've synthesized and studied several compounds which contain molecular water and hydroxyl group. So it would be natural to apply infrared or Raman spectroscopy to explain the ratio of two types of water, and so that would make your conclusions but more substantiated. And the third comment is important for me personally. Is it in a thesis? The thesis a lot speaks has a large annex which explains these synthesis methods and how your experiments were carried out, but along with successful, you had lots of unsuccessful experiments. So to talk about your successes of your method or your improved method, I think it would be good to mention that the use of this and this will lead to obtaining such and such structural type, because I think there was this element of accident there, and the work, of course, is good, and the author certainly deserves the degree. That's beyond any doubt, and I think it stands out. The completeness, the knowledge, the focus of the applicant really remarkable. Thank you. Elena Vitalievna, thank you. Alexei Ilyich, will you please continue? I will be brief because a lot has been said already. I enjoyed reading the work very much, and it is good, provided good evidence of the author's maturity, and also the presentation was excellent. 6 publications, 6 articles. So all this, of course, so mineralogy crystallography is also reasonable because many tasks are solved on the but there is an interesting point. In the first statistical part, you used a very interesting approach, the inductive approach, where you use a set of truths and then apply them to your analysis in crystallography. This approach was used many times. If we look at the conclusions, there's 32 types of symmetry, and this also, so it was used in many studies, this approach, and but today I think there is still a lot to work on here. So there is still some challenges to be explored, challenging parts. So this approach that you used is not conventional in such classical chemical geology, which is a more deductive approach, and so such philosophical deviation made your work. You can your thesis can be non-organic chemistry and material science, is chemical technology and geomaterials. But since you chose geology and mineralogy, as is traditional in your department, crystallography, mineralogy, of course, so we will respect your choice. So that's your choice. But I think you had these opportunities, and you had this opportunity to, and see, you have a great sense of humor, because the 4th provision cannot be taken as cannot be seen as a joke. so it's better, but I can't see any, I don't see any, but of course sense of humor should be used when appropriate. So don't make such jokes when presenting your thesis. But I am on your side as a matter still. And I have to read the last paragraph of your thesis, that the thesis corresponds to the requirements set by the order number dated the 19th of November 2021 on awarding degrees at St. Petersburg University, and the degree applicant deserves the degree of candidate sciences, specialty 164, mineralogy, crystallography, geochemistry, and geochemical methods of mineral exploration. Articles 9 and 11 have not been violated. Thank you. Thank you, Alexei Ilyich. Tatiana Borisovna, can you give your opinion about the thesis? Can you hear me? Yes, we can. I agree with the opinions given by my colleagues. The thesis makes a very positive impression. And there's the statistical chapter, experimental chapter, the empirical chapter. The sound is not good. As per the experimental part, I have some minor suggestions connected with this part. So these are the questions. I think I tried to ask a question when in transition from chapter 1 to chapter 2, why exactly these objects were selected. Of course, you probably managed to synthesize some things and failed to synthesize others. And why have you chosen exactly these ones? This is not clear. And the second point was already mentioned. This is provision 4. I could not see the size of your crystals. Many, or maybe photographs. What were they like? So this method is well known for synthesis, sulfides, and as new. Why have you included it as a separate provision? So it's also not clear. What could you explore except for the minimum size? And here I'd like to proceed to suggestions. This hopefully you'll continue, these studies will continue to bivalent copper. So it would be interesting to study the newly synthesized compounds, magnetic. So what's the actual environment of this copper? I think such studies would be interesting will be interesting in the future, because this data is possible to compare the real structure and the data obtained through analysis, and so the work is very good. I have not found any typos. And I think I have to read the last part. I think the thesis by Kornyakov Ilya Viktorovich on synthesis and crystallography of new mineral-like compounds of bivalent copper corresponds to the main requirements set by the order of awarding academic degrees, and the applicant Kornyakov Ilya Viktorovich deserves awarding the degree of candidate of geology and mineralogy in mineralogy, crystallography, and geochemical methods of mineral exploration. Articles 9-11 of the above-mentioned order has not been violated. Thank you for your attention. Thank you, Tatiana Borisovna. I think the sound was not good. Maybe I can read the questions if the applicant missed, if our applicant missed something. And then, Professor Hawthorne, please give your review, your opinion of Ilya's work.
Okay, first, I'd like to say how much I enjoyed reading this thesis. The science is of high quality, and the coverage of the subject area is both detailed and extensive. As explained by Mr. Kornyakov, divalent copper has very interesting stereochemical properties due to the Anteller effect. Because of these properties, solid solution of divalent copper with other divalent ions of similar coordination is more complicated than is usually the case for divalent cations, a situation that has generated a lot of crystallographic work on copper oxysalt minerals and their synthetic analogues. Partly because of the presence of copper 2+ and copper 3+ in high temperature superconductors, there has been a lot of work reported in the physics and chemistry literature that has both drawn on previous work on minerals and extended it to non-mineral phases of great physical and technological interest. This synergy has led to much new science. For example, the search for quantum spin liquids in mineral and mineral-like structures, and the recent discovery of its presence in Herbert Smithite. Detailed analysis of copper oxysalt minerals was presented 20 to 30 years ago. And since then, there have been numerous discoveries of new copper oxysalt minerals and discovery of the presence of novel physical properties, such as high temperature superconductivity and quantum spin liquids in copper oxysalt structures. Consequently, it is long past time for a new detailed examination of copper oxysalt minerals from a structural perspective. And Mr. Kornyakov has done this extremely well in this thesis. He is comprehensive in his coverage of copper minerals and has extended the hierarchy to some synthetic copper oxysalts. In particular, he has extended the hierarchy to include anion-centered OCU4 copper oxysalt minerals and synthetics, something that was missing in previous classifications of copper oxysalt minerals because of the previous lack of appreciation for this type of coordination prior to the work of Stanislav Filatov and Sergei Krivovichev. I don't have questions, but I have a comment. Mr. Kornyakov emphasizes that copper-centered polyhedra are attached from both sides of the layers to form a kagome net of copper atoms. This is a very important statement. And when Mr. Kornyakov publishes this in previous papers, I'd advise him to describe this net in more detail. It should be explained and the linkage between the copper atoms and other linkages be described in this net. Now, this is an extremely interesting observation. The kagome net of copper atoms also occurs in the spin-half kagome lattice antiferromagnetic Herbert-Smithite. I and others have often speculated that many other copper oxysalt minerals, based on sheets of edge-sharing divalent copper octahedra, should also exhibit interesting physical properties such as superconductivity and quantum spin liquid behavior because of the constituent kagome net of copper ions. This is something well worth further investigating, particularly in terms of the details of the copper-copper interactions that give rise to these interesting properties. Work of Mr. Kornyakov presented here on the structure hierarchy of copper minerals provides the structural framework to make this analysis. And I would suggest that he does so in future. In summary, this is an excellent thesis and deserves a PhD. Thank you.
Спасибо.
Thank you, Professor Hawthorne. And now I will probably present my review, and I think I agree with all the positive as well as negative remarks. Of course, this unlucky provision 4. So I won't talk about the advantages. We already mentioned here articles and works. Something I didn't like, that's relevance. So the geological part, which is very loosely connected with the rest. I'm sure there is chemical relevance. So you should pay more attention. Forget Kamchatka, those minerals in Kamchatka. And I agree that the work is very well written, but I still have 3 comments which made me puzzled. So there's mineral-like compounds. So we have non-mineral-like compounds. And how do you differentiate between mineral-like and non-mineral-like? The second phrase I didn't like is the perovskite compounds. What are those perovskite compounds? There are calcite compounds. I have studied calcite for many years. I don't understand this phrase. And finally, let me the perovskite formula and to say oxygen containing perovskite. So, or either you don't need either the first or the second word, or it's some oxygen compound or perovskite. And of course, Ilya Viktorovich by all means deserves awarding the degree of candidate of geology and mineralogy. And that's another good example of how the Department of Crystallography works and how it educates, how it trains young scientists and present their thesis, submit for defense. I think we will stop here. So you have now some minutes to answer the main critical remarks or questions. Thank you very much, dear council members. Let me start with the most important comment about provision 4. Of course, as Olga Viktorovna said, we don't have a single provision submitted for defense in the statistical part. That's bad. So the theoretical part So the theoretical part we've done a long time ago, and by the time I wrote my thesis, it already appeared old to me, and that's the reason why this happened, and why the wording of proposition 4 is so bad. Well, I agree. The wording is very weak, and I will certainly keep this in mind in the future. Now, there were some questions about the additional methods, the chemical analysis. Tatiana Borisovna proposed the electron or paramagnetic resonance method. Let's go to my additional slide. So, well, the additional, and we did some additional analysis with microscopy, and as this slide demonstrates, the chemical analysis for arsmirandite compounds, the first two, the rhomboedric. As you may see, the qualitative part of our analysis demonstrates that they are quite pure. Second has some silica impurity, maybe because of comes from the ampule walls, and the qualitative part was done on a fairly high level. But according to the formula and the charges, we found something very interesting. All the analysis with arsmirandite clusters, they have excessive negative charge from 0.03 to 2 units of charge, and we couldn't find the reason for this, so we decided not to include this result in our work. And on the left you may see the crystals that we synthesized. And question, now we may proceed to the synthesis question. The synthesis questions, as I said, the chemical composition was selected empirically, and maybe I should have explained the empirical part on the analysis that we have conducted and the results we have obtained, the side phases we obtained. This is also an omission. And as for the additional methods, because of the selected synthesis method, obtaining pure monophase substance was difficult, was hard, because at the same time we got hard phase synthesis and gas transfer or vapor transfer synthesis, and it was hard to balance the two, and many of the phases we obtained never crystallized in oxygen or media. That's why obtaining pure monophase sample for further study, including the water compounds with AH2O and hydroxine, molecules, that was a challenging task. And so first of all, we have to say that all the compounds with H2O and hydroxine were obtained accidentally. These were all side molecules, and they all crystallize in selenite systems, which is very hygroscopic. So it absorbs water. When you start heating it, so selenite starts to evaporate. So it was hard to take water out of this synthesis. So obtaining these substances, pure monophase samples, I failed to do this. Maybe, perhaps, this could be done. I tried to add water, but on purpose. But here the risk is high that the ampoule would explode, because when the temperature increases, water pressure increases, and it bursts inside the furnace. So it's necessary to be very careful, select volume and amount of water. Maybe can do that in the future. That's what I wanted to say about additional methods. I think I already explained the composition. And there was this question about the Cherevskite phase, which has an ugly formula. Let me find it. Here it is. Well, hold on a second. The fractional coefficients occur because of different degrees of oxidation of copper and potassium, and because of poor repeatability. This phase was obtained together with the archetype in the same synthesis on the walls. And repeatability was very poor, very low. I only managed to repeat it once, and I only get 1 or 2 crystals. And because of small amount of substance, I could not conduct the chemical analysis, so I just lost these crystals. But because of different nature and different atomic masses, you can tell between the two using the radar structural analysis, which we used to calculate the formula. Let's move on. As for biomineralization and right, about biomineralization was mentioned in part 1 under relevance. And besides, the structural part of minerals was described in the overview. Moldavite indeed I missed for one simple reason. I have not found emulate experimentally obtained structure, only calculated structures. So I thought to include the calculated structure in the thesis is incorrect. I know that you are studying this structure, so once the structure gets published, I will certainly include it. As for relevance, that's also my omission, my mistake. I wrote this chapter as an introduction. I did not understand the task properly I had to achieve in this chapter, but I will certainly keep that in mind. The mineral-like compounds and perovskite compounds. In our work, the mineral-like compounds, the phrase is used to emphasize that these phases are similar to those found in nature. For example, the study of crystal chemistry of copper is connected with that. First of all, there are large overviews in crystal chemistry of copper, where they mostly explore the mineralogical aspect is often omitted. by my colleagues. So we did, as for both, for not only for crystal chemists but also for general chemists, it would be useful. As for perovskite, the term perovskites in our work is used not from the point of crystal chemistry to emphasize the structural connection between the perovskite, the similarity in structures. I was guided by works by Roger Mitchell, who has a very good book, Perovskites, where he kept saying perovskites, and he has an article on nomenclature of perovskites, where he also calls artificial minerals perovskites. So I thought it's a good idea to follow his example, follow his logic. And separately, well, maybe that's it. Maybe there was something else I forgot. I think that's it. Ilya Viktorovich, thank you. This is a question for the council members. Are you all satisfied by Ilya Viktorovich's answers? Or perhaps you have... So everybody's happy. Okay, now we can proceed to discussion. Is any of the guests willing to speak and maybe discuss, give his or her opinion? Now you have the opportunity to do so. No, I see nobody's willing to speak. And now, have we received any questions by email? No external questions. So we have nothing to discuss here. And Sergey Vladimirovich, will you please talk about the applicant and his impression about everything? Dear council members, dear Nikolaevich, dear colleagues, first, I'd like to thank the council members and the chairman for your interesting comments, careful review, and positive evaluation. Indeed, everything you said is very much to the point about the in-depth questions asked by Professor Hawthorne. I have answers to all three questions. So maybe perhaps we shall get in touch and I can send my answers. Your questions were very interesting and very in-depth in the field of crystal chemistry. Here's what I wanted to say. This work really follows the traditions of the crystallography department of St. Petersburg University. First of all, it's connected with copper minerals of fumarole origin, which were described by some of our outstanding scientists, including Professor Filatov. So that's our traditional theme. And transport reactions, as Professor Nazarchuk said, the gas phase transition. As for the thesis itself, I'd like to say, from the point of chemical synthesis, most compounds were obtained while we were searching. And the most interesting, from the point of experiments, these were arseniuramide clusters. These were synthesized on purpose. So that we were not simply trying to synthesize something. So these were attempts to synthesize analogs to these minerals, which were discovered by Igor Pergov and described by Professor Britvin. So this is pure experimental mineralogy, to synthesize analogs of particular minerals. And so chemists got very interested in these clusters, because before these clusters it was not possible to obtain these clusters. And when our article was published in Scientific Reports Journal, we got, at least I got, as the author, I got responses from chemists. So they were searching how to get these clusters, and we managed to synthesize them from the gas phase. So I wanted to emphasize this because mostly we talk about explorative chemistry, and most works in our department. So mostly these are research papers. As for Yuri Viktorovich as a person, I think he has all the properties of a real researcher. He's very interested in his subject, and he's very independent. He can set himself the tasks. As for the language of the thesis, I have not edited the Russian and the English text, and I'm very happy that the Russian text is well written. I also think so, but I have not edited it. And of course there were comments about the English translation, so but I have not edited either. I'd like to say that here Ilya Viktorovich, in this sense, he has a great future. And also I wanted to talk about the continuation of this work, the theoretical part. The theoretical part is much richer and much more diverse. It has not been published yet, and also maybe I have to say that maybe it's my initiative. It was my initiative to save this part for the next thesis, which hopefully will be written soon. We have lots of experimental materials that have not been published yet. And finally, about the fourth provision. So we didn't know if we should add 3 more provisions in 6 provisions or only 4. But the fourth provision make it so trivial. So to make the material of the published to include it in the work. And I'd like to finish maybe with a non-scientific comment. I just came back from Syktyvkar. Syktyvkar, the northwest 800 kilometers north, there's Usinsk. That's where Ilya Viktorovich was born. And I wanted to say that not always we cannot fully evaluate the potential of our people who indeed and our land that where such people can be born. I won't compare Ilya Viktorovich with Michael Lomonosov. Well, actually, he lived here closer to Moscow and to St. Petersburg, and Ilya Viktorovich the distance Ilya Viktorovich traveled is 2 times greater. But of course, today you can travel with more comfort. So I wanted once again to thank the council members for such detailed reviews and wish Ilya Viktorovich to stay as focused and as intense as he is, and wish him with such approach. I think his future successes are very near. Thank you for such kind presentation, dear colleagues. Now I have a question for all the council members. Is anybody else still willing to speak with further comments, points for discussion? If nobody is willing to speak, at that our discussion is over, and we won't take any more questions. Before we vote, I have to ask the council members and the applicant. Also, if the council members or the applicant have any comments or questions regarding the procedure of today's session, especially those of you working remotely, and I have to ask each of you if you have any questions or comments about the procedure. So if you have questions, please say so. Olga Viktorovna, you have any questions? I beg your pardon. Of course, there's a problem with remote access. There was. We could not hear. We couldn't hear the speakers. Of course, we could guess. Well, from Canada, we could hear everything very well. We couldn't have any difficulty. From Canada, we could hear our Canadian colleague much better. I don't know. So we understood what the council members said, because, so first of all, we could guess, and when Ilya answered, I think, okay, in any case, the review is available at the website. Igor Viktorovich, do you have any questions? Besides this technical issue, I don't have any comments. Thank you. Elena Vitalyevna? I have no comments. Alexey Ilyich, no comments. Tatiana Borisovna? I have no comments. Everything was clear to me. And so the last, Professor Hawthorne, do you have any comments?
No further comments.
Yeah, thank you very much.
Thank you. Then, dear colleagues, I'm asking the council members, before we vote, we have the opportunity to take a break to discuss the results. And at that, sound shall be switched off and we can have a private discussion. Do you think we need to discuss anything privately, or we can proceed to voting? I think everything is clear and we don't need private discussion. So we'll proceed to voting. Everybody's okay with that? Okay, thank you.
Yes.
Then I put the question of awarding to Kornyakov Ilya Viktorovich I have to give the exact time is 5:49 Moscow p.m. Moscow time, and I put the question of awarding to Kornyakov Ilya Viktorovich the degree of candidate of geology and mineralogy, specialty 164, mineralogy, crystallography, geochemistry, and geochemical methods of mineral exploration. Let me emphasize that by voting for, each council member agrees that Articles 9 and 11 of the order has not been violated. Let me quote this Article 11. In his thesis, the author has to refer to the source of borrowed materials or results. When using results obtained by the applicant personally or in co-authorship, the applicant has to mention this circumstance in his thesis. Let me remind you that a decision of the Council on awarding or not awarding the degree shall be considered positive if two of more than a half, but not less than 3 Council members, I think 4 in our case, of the Council voted for it according to Article 23 of the order. Let me ask the Council, Council Member Brusnitsa Alexei Ilyich. Your opinion? I vote for. Thank you. Olga Viktorovna? I can support. Thank you. Igor Viktorovich? Of course I vote for. Thank you. Elena Vitalyevna? I vote for. Thank you. Tatiana Borisovna, your opinion? I vote for. Thank you. We heard you. And Professor Hawthorne, your opinion, please.
I vote for.
Спасибо.
Thank you. We heard you. And my opinion as the chairwoman of this council is also positive, and I think that now we can count the votes and I can announce the results. Dear colleagues and guests, let me inform you that out of 7 council members who voted, 7 voted for, nobody voted against, and nobody abstained. Their decision to award to Kornyakov Ilya Viktorovich the degree of Candidate of Geology and Mineralogy, specialty 164, Mineralogy, Crystallography, Geochemistry and geochemical methods of mineral exploration has been made. Now we can give the floor to the applicant for his closing remarks. I would like to thank all the council members, and especially I'd like to thank those working in remote mode. Professor Hawthorne, Elena Borisovna, thank you. A special thanks to Professor Hawthorne for his questions, to which unfortunately I could not answer. But after now I'm going to explore this in detail. And many thanks to my thesis supervisor for his kind comments, and to all the guests. Thank you. Thank you. Then, as a chairman, I think I have the right to congratulate you on behalf of the council members and all the guests. I'd like to wish you all the best. Please remember your university, come work at our university, and all is well. At that, our session, I declare our session closed. Let me thank everybody for taking part. For some of you it's very early, for some of you it's very late, so please stop broadcasting. Thank you very much.